Hello there, welcome to Umid Private High School online classes. Today in this session, we are going to study about some topics of 11th grade geometry. And we start from remaining topics. And today's first topic is positions of two lines. Positions of two lines means the geometrical relationship between two lines. What kind of relations they can have? They are parallel to each other, they are coincident with each other, or they intersect each other. We just study about these kind of relationships between 2 points. Okay, to analyze the relationship between 2 points, we just check the coefficients of two equations. Just coefficient of variables in both equations. Coefficient, I mean here, the adjacent number to these variables x and y in both the equations, and also ratio of these constants. Okay, we check the ratio of these numbers to decide the positions of two lines. How we can determine here? First, we take the ratio of coefficients of x. Coefficient of x, I mean a1 divided by a2. It means ratio of coefficients of x. Coefficient of x in first equation divided by coefficient of x in second equation. If it is equal to the ratio of coefficients of y, means b1 divided by b2. b1 is coefficient of y in first equation, b2 is coefficient of y in second equation. Then if they are equal to the coefficient ratio of constant values, c1 is constant in first equation c1, c2 is constant in second equation. If these ratios are equal to each other, it means these two lines are coincident with each other. Coincident with each other means they are equal to each other. You see here, line number 1, line number 2. They are exactly on each other. It means they are coincident. Second, if the ratio of coefficients of x is equal to the ratio of coefficients of y, but not equal to the ratio of constant values, then these two lines are parallel to each other. Parallel means they do not intersect each other, and their slopes are equal. Just see the diagram here. Line number 1, line number 2, they are parallel. Their slopes are equal. They do not intersect each other. For third case, if ratio of coefficients of x is not equal to the ratio of coefficients of y, then these two lines intersect each other. It means they have one common point. They have one intersection point. Just see the diagram. Line number 1, line number 2. You see, they have intersected each other at point A. So they are in intersection lines. Next, let's solve some examples related to this topic to make the concept more clear. Determine, example number 1, determine the position of the lines x minus 3 plus 2 equal to 0 and 2x minus 6y plus 4 equal to 0. We should determine the positions of these two lines. For that, we just check the ratios of coefficients. So a1 divided by a2. a1, you know, coefficient of x in first equation. Here coefficient of x is 1. a2 is coefficient of x in second equation. It is 2. 1 divided by 2, and it is equal to 1 over 2. Next, ratio of coefficients of y. b1 is coefficient of y in first equation, minus 3 divided by b2 is coefficient of y in second equation, minus 6. Finally it is 1 over 2. Ratio of constant value, C1 over C2. C1 is constant value in first equation, that is 2 here, 2. Divided by C2 is constant value in second equation, 4 here. So 2 divided by 4 is equal to 1 over 2. You see here result is same, 1 over 2, 1 over 2, 1 over 2. It means these two lines, this line and this line, they are coincident with each other. They are coincident. Okay, let's continue solve next example. Example number 2. X plus 2y minus 2 is equal to 0 and k minus 1 into x plus y plus 4 equal to 0 are parallel to each other. Okay, they are parallel. You see, if they are parallel, then we should calculate the value of k. How we can calculate? We know if they are parallel, the ratio of coefficients of x is equal to the ratio of coefficients of y. Means a1 divided by a2 should be equal to b1 divided by b2. So e1, you know, a1 is ratio of coefficient of x in first equation. Here it is 1 divided by a2 is coefficient of x in second equation. Here it is k minus 1 equal to b1 is coefficient of y in first equation. You see here it's 2 divided by b2 is coefficient of y in second equation. Here it is 1. Okay, now cross product. 2 times k is 2k minus 2 times 1 is 2 equal to 1 times 1 is 1. See, so 2k is equal to 3 and k is equal to 3 divided by 2. This is how we calculate the value of k using the concept of positions of lines. Okay, let's continue for the next example. Example number 3. Find the intersection point of the lines x minus 2y plus 6 equal to 0 and the line minus 2x plus 4y plus 6 equal to 0. We should find the intersection of these two lines. Okay, we don't know they have intersection point or not. For that, we should check their positions according to each other. What kind of geometrical relations they have. First, we should check, then we will say something about their intersection points. Okay, let's check their positions, their relations with each other. It means we should check a1 divided by a2, b1 divided by b2, and c1 divided by c2. We should check these ratios. You know a1 is coefficient of x in first equation. It's how much? 1. You see here it's 1 divided by a2 is coefficient of x in second equation. It is minus 2. So minus 1 over 2. b1 is coefficient of x, coefficient of y in first equation. It's how much here? You see minus 2 here. So minus 2 divided by b2 is coefficient of y in second equation. It is 4. So this one also minus 1 over 2. Now let's take the ratio of constant numbers. C1, you know, constant number in constant value in first equation. It is 6 as you see here. 6 divided by C2 is coefficient constant number in second equation. This one also 6 equal to 1. Okay, you see b1 over b2 is equal to a1 over a2. a1 over a2 is equal to B1 over B2, but not equal to C1 over C2. You see the results? A1 over A2 equal to B1 over B2, but not equal to C1 over C2. So these two lines are parallel to each other. See? Parallel. It means there is no intersection point. Okay? Now let's continue. Let's see some more example. Example number 4. Again, they are asking intersection point. Again, let me tell you that we cannot say anything about their intersection points if we do not check their geometrical relationship. So let's check their geometrical relationship. A1 divided by A2, B1 divided by B2, C1 divided by C2. We should check these ratios. A1, you know, coefficient of x in first equation. You see, it is 3 divided by A2 is coefficient of x and second equation. It's minus 6. Finally, it is minus 1 over 2. Next, B1, you know, coefficient of y in first equation. You see coefficient of y here, it is minus 4. So minus 4 divided by B2 is coefficient of y in second equation. It is 8. And finally, it is minus 1 over 2. Next, C1 divided by C2. You see, it is constant value. So C1 is constant value in first equation, that is 12. 12 divided by C2 is constant value in second equation. It is minus 24. So 12 divided by minus 24, and this one also equal to minus 1 over 2. You see, the result of all these ratios are equal. You see, all of them are minus 1 over 2. It means that these two lines are coincident with each other. Coincident. Coincident. So they have countless number of common points. Infinite number of common points are there, not a single intersection point. They do not have a single intersection point. They have infinite number of intersection points. This is your homework. Check yourself. Number 16 is your homework. 2 questions are there. Okay, thank you so much. In the next session, we will talk about angle between two lines.